Today, we'll be solving a combination resistive network. So in this circuit, you can see that I've got a 5-volt battery connected with a weird combination of 5 resistors. So we are going to go ahead and try to solve this and find the equivalent resistance of the circuit and determine all the voltages and currents. So as usual, first I'm going to mark all the nodes so that we know which combination of resistors is present here. So the first node would be between VT and R1, and this would be marked as node A. Then we are going to trace all the way to another junction point of electrical components like this, and we're going to mark node B over here. Next, I can spot node C, and then this would be node D. Since there is no component in between this node and VT, so we're not going to mark any new nodes because this is actually the same node. So this would be node D, and this would be node D as well. Now that all the nodes have been marked, we will start identifying which combinations of resistors are present in the circuit. So you have to start from the resistors that are farthest from the source. In this case, the resistors over here to the left. So I'll start with the resistor 5. R5 is connected to R4 and R3, but I'm going to check in which combination they are attached. So for me, an easy trick to determine the combination of any resistive network is through currents flowing in the. So we will draw a current that starts flowing from VT, passes through R1, and then it reaches to node B. It then divides into 3 parts. One is going from R4 to R5, the another one from R3, and the another one through R2. Next, I will mark these currents for better understanding. So this is I1, I2, I3, I4, I5. So basically, you can see that R4 and R5 receive the same current, so these will be in series. So we can find our first equivalent resistance, R6, simply by adding R4 and R5. This is 2 plus 4, which will give you 6 ohms. Okay, now we will just replace these two resistors and place R6 between nodes B and D. I have already drawn the circuit for you over here. Now you can see that R2, R3 and R6 are connected with the same nodes, so they are in parallel, right? So now we will solve this parallel combination. Now we will find the second equivalent resistance, R7, simply by using the formula for parallel combination, which is 1 over R7 is equals to 1 over R2 plus 1 over R3 plus 1 over R6. This would be 2 over 3, and R7 would be 1.5 ohms. Now I'm going to draw R7 over here in place of these 3 resistors like this. So we get this circuit, and now we are just left with R1 and R7. It is quite obvious that this is a series combination. So we will solve this series combination first. So for this series combination, we simply have RT, which is the total resistance, equal to R1 plus R7. That would be 2 plus 1.5. This is simply 3.5 ohms. Next, we will find out the current. So we will use the Ohm's law to calculate the total current, which is, so Vt is equal to IT RT. IT would be Vt over RT. From this table we have IT as 5 and RT as 3.5 ohms. So IT will be 1.42 amps. So the equivalent circuit diagram would be where IT is the total current passing through it. So for total current we will use Ohm's law, which is Vt is equal to IT RT. IT is Vt over RT, which will give you 5 over 3.5. So IT will be 1.42 amps. Next, we will find out the current through all of these branches. Since the total resistance was the series combination of R1 and R7, So whatever current is flowing through the total resistance is actually flowing through R1 and R7. So I1 is equal to I7 and it is equal to total current, which is 1.42 amps. Now we can calculate the voltages across respective resistors. So V1 would be I1 R1 into 1.42, that will be 2.84 volts, and V7 will be I7 R7, that is 1.5 into 1.42, which is 2.13 volts. Okay, next look at the circuit over here and you see that R7 is actually composed of R2, R3 and R6. So whatever current is flowing through R7 is actually divided into these three currents, I2, I3 and I6. Since they are in parallel, so their voltages would be same, which is VBD. So V2 would be same as V3, which would be same as V6, which is V7, 2.13 volts. So we can find the currents using Ohm's law. I2 is V2 over R2, that is 2.13 over 3 ohms, which is 0.71 amps. I3 is V3 over R3, that is 2.13 over 6 ohms. This comes out as 0.355. Similarly, I6 as V6 over R6, which is 0.355 amps. Okay, so that was a bit complex. Now we are just left with the last two resistors. Remember that we marked R6 as combination of R4 and R5, as we can see in the circuit diagram. These two resistors, that is R4 and R5, are connected in series. So whatever current is going through R6 is also going through R4 and R5. So I6 is I4, that is I5, which is equal to 0.355 amps. Next, we are just left with the voltages of R4 and R5. So we are going to use Ohm's law. So V4 is I4 R4, which is 0.355 into 2. That will give you 0.71 volts. V5 is I5 R5, which will be 0.355 into 4, and this will give you 1.42 volts. Next, we will just fill in the values in the tables. I4 is 0.35 amps. I5 is also 0.35 amps. Similarly, V4 is 0.71 volts and V5 is 1.42 volts. Right, so we have calculated all the values and that is it for today. If you like the video, then give it a thumbs up, subscribe to our channel and come back next week for more content like this. If you have any suggestions or you would like to see a video on any topic, please let us know in the comment section below.